Hello guys, welcome back to Mr. Cloudbook channel. Today is the day 49 of the Kubernetes Masterclass, and in this video we are going to learn about the persistent volumes and persistent volume climbs. And in the simple way I will explain what is the persistent volumes and persistent climbs as well. So imagine you are in a big school. Okay, this is one of the big school, and every student needs a locker to keep their books and lunch box. But you can't just take any locker, you have to request one from your school. This is exactly how persistent volumes and persistent volume clients works in Kubernetes. Okay, so persistent volume in the school way. So the school lockers, okay, the school already has a lockers installed in the hallway. Okay, each school have some kind of lockers installed in the hallway. Maybe you see in the movies as well, right? So there is so many lockers in the school, right? We have to provide for the students. That particular school management will provide it. Some lockers are big and some are small and some are even special ones with the security. Okay, so every locker having different kinds of features. Okay, the higher class students needs the bigger locker. Our main always are the main CRs and some high representatives school leaders needs this special particular locker, right? The school, I mean the Kubernetes owns these lockers, but students can use them. Okay, here this is school. Okay, we can call it as the Kubernetes. Okay, so the lockers in the school in Kubernetes we can call it as the persistent volumes. Okay, so these are owned by, so these particular lockers owned by Kubernetes, but we can use them. Even if student leaves for the day, their locker stays in the hallway with their books inside. Okay. Even students take a sick leave, his books will be there in his locker. Whenever he leaves, okay, the school, then only he will make it empty and he will leave. Okay. So, but these books can use it by some other students as well, right? In the hallway locker, because so many peoples will join the same class, juniors will become seniors, like that, right? So in Kubernetes the persistent volume is like these lockers. It is a storage space already set up for and available to use by the students or by the applications or by the pods. Okay, persistent volume climbs asking for the locker. So we have lockers. Okay, here we have the lockers, right? Three lockers we have, or so many we can have, because this is my school. I can keep it how many I want in the hallway. Okay, so these are all lockers. So students will come. Okay, each student will have different, right? So this guy will get one locker, this guy will get another locker, and this guy will get the different locker. Okay, so we have to request for the locker. So we have to tell the school management that I need the locker. So persistent volume climbs works like that. So you are a new student and need a locker to keep your books safe. So at that time, what you have to do, you have to go to the particular school management, or in the application needs some kind of storage that needs to go to the Kubernetes. Okay, you go to the school office and request a locker. This is the PVC. In your request, you mention what kind of locker you need. So how much size you need, what kind of type you need, open self, like locked one. So there are different kinds of lockers will be provided. The school office checks if they have an available locker that matches your request. Okay. So this particular locker will be available or not. Okay. The students needs the bigger one and needed the locked one. So it will, the school management will check it, and then only it will allocate particular locker. Okay, same likewise, if they do, they can give you the locker, and if you don't, that you can't provide. Okay, so either they have to build or they have to ask someone else. So in Kubernetes, a persistent volume climb is like your request for the locker. Your pod ask for the storage, and if there is a PV, okay, available that matches your Kubernetes, will assign it to you. This is a simple way. Okay, so we have the locker and we have to request it. Okay, these lockers. This school is called the main Kubernetes. These lockers are called the Kubernetes persistent volumes. Okay, this is PV in a simple word, and these are all PVs. And if you want to understand more about the PV and PVC, you can read most of the configurations from the kubernetes.io page. Okay, the key features of PV is independent of the pods. Even if pod crashes or it's deleted, the data is in the persistent volume remains same. Okay, it provides the agonist. I mean, like it will support so many kinds of provider various storages like AWS, EWS, uh, sorry, it will provide the so many kind of cloud providers, backend storage providers like AWS, EBS, Google Persistent Disk, NFS, ISCSI, so like that. So reusable. Once a pod is no longer using, PV can be reused by another pod. Okay, if locker is empty, so another student can use it, right? Likewise. So persistent volume climbs. It's like dynamic and pre-provisioned. Kubernetes can dynamically create a PV based on the request. PVCs are matched PVs already existing. Okay, so which ensures the compatibility also. PVC will only bind to the PV that meets the resource requirements. Okay, so the workflow, how it will work. Okay, so first of all, we have 5 kind of steps. So first one is admin. Okay, well, admin what will do? He will create the simple persistent volumes for you for your application. Okay, these could be a local disks or like that. So the application creates the app, creates the PVCs. Okay, here admin will create the PV, application will create the PVC. Application requests storage by creating the PVs. They specify desired storage size, access mode, and other requirements. Then what will do? Kubernetes, okay, will match that particular PVC to a PV. So this will match this particular PV. This will looks time, okay, it will take some time. The Kubernetes control panel will automatically look at available PVs and find the matched one and attach your PVC to that particular PV. Pod uses the storage. This is the 4th step. Pod usage. Pod uses your PVC. Pod will use it. And 5th one, storage persistent beyond app lifecycle. Okay, so this is persistent. So even if you pod is deleted, okay, my pod, what happened here? So it's deleted. It's no longer needed for me. So what happens? So it will delete the PVC, but it will keep the PV in bond. Okay, it will be persistent. Okay, it will stay like that. That is the simple explanation of how it will goes. Okay, but if you go to the kubernetes.io page and search for persistent volumes, okay, here you can read more from the persistent volumes. So I'll go here, you can check here where what you want, or you can click on here persistent volumes like that. So life cycle, volume and claim. See, provisioning. There are 2 ways PVs may be provisioned: statically, dynamically. Statical means a cluster administrator creates. Already explained, admin will create the PVs. Okay, dynamic means when a none of the static PVs the administrator created matches a user's persistent volume claim, the cluster may try to dynamically provision a volume by specifically per the PVC. This is the dynamic. And binding. So once that is done, okay, we created it. So then what we will do? It will application will ask for the PV, and then the loop will always bind that PV to the other PVC. Okay, you can read it from more here. Okay, user creates, or in the case of dynamic provisioning, as it's already created, a persistent volume claim with the specific amount of storage requested and with the certain access modes. Okay, so this is the binding, and next pod will uses that particular volume or the claim. Okay, the cluster inspect the claim to find the bound volume and mount the volume as a pod. So storage object is in the production. The purpose of the storage object in the production features to ensure that persistent volume claims PVCs is active used by the a pod and a persistent volume that are bound to PVCs are not removed from the system. Okay, so these are all, you can read it from here itself. If a user deletes a PVC in an active use by a pod, the PVC is not removed immediately. The PVC removal is postponed until the PVC is no longer actively used by any pods. Okay, so if you are using one pod, you attached one PVC. to one pod. Okay, and you don't want any more PVC. If you try to delete it, it will delete, but it will under delete state only because that pod will use it. If you delete the pod, then only the PVC will be deleted. Okay, remember that. And reclaiming. So when a user is done with their volume, they can delete the PVC object from the API that allows reclamation of the resource. Okay, retain means the retain reclaim policy allows for manual reclamation of the resource. When the persistent volume claim is deleted, the persistent volume is still exists and the volume is considered as the released. Released means we can use it, but is not yet available for the another claim because the previous claim data remains on the volume. Okay, so what happen if you use this retain option in the reclaiming process? This will remove the, I mean, like whatever the PVC is created by your application, it will use PV. But once that is done, it will not usable by any other pod. See, but it's not yet available for any another client because the previous claim data remains on the volume. An administrator can manually reclaim the volume with the following step. So we have to manually reclaim it using the retain. So delete, how to delete the simple PVC. And these are all how to attach the PVC or PV to your particular pod. You can say this is pod YAML file up to here and containers, but this is the volume they are adding. So which is comes from your particular PVC. So volumes name host path and we have to attach inside our container. So whatever the volume we are adding here, this particular volume will be used by this particular container. Okay, so this is the mount part. This is the volume name. You have to provide the same volume name here. Okay, this is the simple one. And persistent volume deletion after protection finalizer. You can read it from here more, but I want to explain important ones here. So these are the file types. You can see that volume claims expanding. So read it. And next we have the types of persistent volumes. See, CSI, container storage, different kinds of persistent volume types we have. So NFS, FC, host path, ICICI. So these are all NFS. Mostly we will use host path. So this is for the local. I will explain it. AWS, you can see that EBS and Azure Disk, it will support everything. So this is the simple one. If you want to use, you can use this one. Okay, volume mode. And you can see that persistent volume policy means recycle. Recycle means we can use it. After if it's release one of the PVC, we can use again PV. So capacity, generally a PV will have a specific storage capacity that sets using PVC capacity. Okay, so it's like we have to provide how much storage we want for that particular PV. Volume modes, you can see that volume mode, these are different times, file system and block, and you can read it for access modes. You can see that access modes are read write ones. The volume can be mounted as the read write by single mode. Okay, read one write once. Access mode still can allow multiple pods to access that volume when pods are running on the same node for a single pod access. Okay, and you can see that read write once means, so if a pod or a PVC is running on the same node, then only it will allow. Read only many means the volume can be mounted as a read only many by many nodes. So any node can use on your cluster. Read write many. So write, see here only it's read write many. So read write once. Read write once pod. So it's like different. Okay, the volume can be mounted as read and write by many nodes. These are the different access modes you have to understand. So you can use RWO, ROX, RWX, ROP like that. So on volume plugins, you can read it here. Reclaim policy, we already talked about it, retain. So we have to manually do the reclamation. And recycle, basically it will delete and we can use it anymore. Next time also. Delete, that is the third one, reclaim policy. And these are the mount options. You can use it if you wanted to. Node affinity. So if you want a pod particular PV needs the node affinity, you can use this one also. Okay, reference. And these are the phase. So whenever you create a simple PV, it will be under available state. Whenever you ask for PVC, it will be under bound state. So whenever you release the particular PVC, it will become released state. Okay, the volume has failed means it's automatically in the reclamation state failed. These are all the four phases we have when you create a PV and when you attach a PVC and when you remove it. So you can use this all. This is the storage class and everything. Okay, let's try to create a simple PV for now. Okay, let me open my cluster for now. So this is the simple persistent volume, API version, kind, metadata. You can provide anything. Labels we can remove, we don't need. Storage class also we don't need. So capacity, we need a persistent volume with 10 GB of storage, and access mode, that is up to you. Read write once means only one node can use this particular one. Okay, this particular PV. Host path, so we are just providing the path. Okay, mount directory. This is like the configuration file specifies that the volume is at mount and data on the cluster node. Okay, so the data will be stored under this particular mount data. So whatever the PV is taking the storage, it will be stored under this particular data on your cluster node. Okay, remember that one. So read write one, you can see that gigabytes like that. Storage class is manual for the persistent volume, that is up to you. So what I'll do is I'll just copy this. So vi pv.yaml, enter. So this is the simple one I'm using. So whatever we need, storage class we doesn't need it actually. So this is fine. Capacity, API version, this is everyone knows. Kind, metadata, name for your PV, and these are all local. This is fine. Labels you can't even provide. Namespace, if you want to provide, you can provide namespace. Capacity means how much storage you want for your PV. So presently we are using 10 GB. So access modes means only one node can use this one. Okay. So host path, we are storing our data. If PV pod is using, it will store data under this one. Okay. So come out of it. So what I will do, apply it, kubectl apply -f pv.yaml. You can see that persistent volume it's created. Okay, let's see cd mount. Okay, data maybe. Okay, it's still not yet created. ls. Okay, we moved here. Okay, that is fine. I think we are in the mount only directly. Yeah, nothing is created for now. It's there directly pv. So kubectl get pv. So we read this. This is the name, capacity, whatever we asked. Access modes, read write once. Retain policy means we have to manually do the reclamation policy. And status is available. We showed it right, available, bound, and like that. Claim, not yet. Storage class, we didn't use any storage class. So it's created at 33 seconds ago. Okay. And this is all simple, and you can see that on the cluster node. So the configuration that specifies that the volume is at /mount on clusters node. Okay, this is fine. You can apply it, and you can see that it is available and it's providing everything. So this is the persistent volume claim. Okay, so the next step is to create a persistent volume claim. So we can use this API version, kind. So PV claim, this is. So what we created, PV volume we created. So now we are creating the persistent volume claim. So storage class we will remove it. So we are using manual. See, this guy is using the manual. So you have to match these values. Okay. So if you use it, and the access mode should be same, read write once. So you can see it from here. So read write once. And the next resources, how much you want. Okay, this is capacity. Here you can see that capacity means we are creating the storage. Here resource means request. We are asking, this particular volume claim is asking, I need 3 GB of data storage. So just copy this, come here, vi pvc.yaml, and paste it. And we need to remove this one because storage class we not used it. Come out of it. So if you try to change this one once, 1 minute, I'll change it to read write many. Okay, let's check it will attach or not. Okay, read write many, we are using different modes. Okay, see what is we are using, read write once we are using. So for PVC we are using multiple, many. Okay, k apply -f pvc.yaml, enter. So it's created, right? And if you see k get pv pvc, maybe enter. That is fine. Let's give comma. Okay, you can say that both are under pending state. Why? Because persistent volume claim is using the read write many. Okay, cat pvc. See what it's using, read write many, but here PV is using the read write once. Okay, So that's why we have to use the correct one. Okay, delete -f pvc.yaml. I'm deleting it. So what I will do, I will again change it back to read write once. So we don't need it. Once, come out of it. So kubectl apply hyphen. Before that, let's see. It's still under pending or get pv. See, it's still available. So k apply -f pvc.yaml and it's created. And if you see now, it's still available. It's still available. It's not yet bound here. It's still under pending state for now. Okay, let's keep it for now. And you can see that we have to apply and it will be like this. Okay, so after create the persistent volume claim, the Kubernetes control plane looks for the persistent volume that satisfies the client's requirement. If the control plane finds a suitable persistent volume, so it will attach it. Okay, so we will wait for some more time and we will see. So we are using read write once. So task volume, these are all. This is by PVC actually. So I don't think it will attach. It's still under available state. Okay, no problem. So that is how we have to create. So if you want to attach it to particular pod, okay, so create a pod. Next step is to create a pod, uses persistent volume claims as a volume. So this is all pod requirements up to specifications, everyone knows. This is volume. Okay, what is the name of your one? This is up to you, you can provide whatever you want. Okay, so claim name, so we are giving this particular name. Claim name, see, persistent volume claim name, so we have to give the PVC name. Okay, so this is the PV name and this is the PVC name, task PV claim. And containers, you can give the name, nginx, port, that is up to you. And volume mounts, so where you want to store the data, say which data you want, so you can provide this one, user share nginx html. What is the name of your volume? So this is the name of your volume, just provide it. So it will create the pod with this particular PVC. Okay, this is all about the simple one. You can read it more. You can delete the pod and PVC like that. First delete pod, then delete PVC, and then delete the PV. Okay, you can remove these directories as well if you wanted to. That is up to you. I don't know why this guy is still available state. Okay, get PVC. Okay, describe PVC task PV client. Okay, waiting for the consumer to be created before binding. Okay, we need to create a simple volume then. So let's create this pod. Okay, let's use it actually. Copy this. What we will do, okay, no problem. This is the simple pod.yaml. So va pod.yaml, paste it. So this is simple pod application. So you can provide any name here. Okay, that is up to you. Remember that, but this should be matched with your persistent volume claim name. Okay, what is your PVC name? Task PV claim is the your PVC name. Just provide it properly. And this is same like containers, image, port, that is up to you. Volume mounts, so what is the volume you want? This volume I wanted to mount to my container, so you have to give this name. Okay, and mount path, so which path you want to mount it. So come out of it and k apply -f pod.yaml, sorry, pod.yaml. Okay, k get pods, it's k under creating state. Okay, container creating, so we can use -w, watch more. So it will take some time, like 15 to 30 minutes, 30 seconds, short, not minutes. So okay, you can see that 18 seconds that is created. So k get pods, that is fine. K get PV, and you can see that. So PVC, it's using 3 GB of storage. Okay, I have 10. See, now it's bound. This is default PVC client. Okay, this is where it's attached. Okay, See, this is still available. One is bound. Okay. K get PVC, enter. And you can see that this is the bound volume. These are all both same. See that names and everything. So 3 GB, where it's coming from, bound. So K describe pod, what is the task PV pod, enter. And if you see here, so volumes, okay, claim name, it's using task PV claim. This is how you can create a simple pods and PVCs. Let's try to get PVC ones. Okay. So I explained if we delete this particular wall PVC, how it will work. Delete PVC task PV client. Okay. So it will be under persistent volume stress. It will be under delete state only. So what I will do, I will just cancel it. And if I try to use force, enter. So it will be under stuck state only. So it won't delete. Okay. So K get PVC again. It's still under terminating state. Why? This pod is using that particular, sorry, 1 minute, let me reconnect again, so it will clear the screen, I think. Okay, K get PVC, see, it will be under pending terminating state because our pod is using that one. So if I delete this one, K delete pod hyphen force, then only the particular PVC will be deleted. Okay, see that there are no form. This is how it will work. Okay, or you can see that get PV as well. Then you can see that it's still under return state. We can use it for now. Let's delete this as well, or you can use K delete simply PV task PV volume, enter. Okay. So this is the simple concept PV and PVC. Mostly try to read and understand it from here itself. These are all simple concept. So you will get the same question. Use these. Okay. So use these only. Don't go to the biggest topics in your PVC and PV volumes because you will get the questions from these three only. Just create, attach it to your pod. That's it. Okay. I hope you understand this video and thanks for supporting and keep on supporting to Mr. Cloudbook channel.